Hello students, today we will learn about the Johnson's method of optimum design. In last session we have covered what is optimum design. Now today we will see the Johnson's method. So there are different methods and techniques available for the optimum design, or we can say optimization. But the Johnson's method is one of the oldest method of the optimum design. So in any design procedure, a number of design equations are used. In Johnson's method, these design equations are categorized into three types. So number one is a primary design equation. So in this primary design equation, that is P.D.E. Then number two is subsidiary design equation, and number three is limit equation, LE. So what is this primary design equation? So it is the most important equation which outlines the most significant functional requirement to be maximized, or the most significant undesirable effect which is to be minimized. So what is the maximum requirement, functional requirement is there, and what is the undesirable effect that we want to minimize? So that will be an P.D.E. equation. For example, we can say in design of tensile bar, the primary design of minimum weight, and the equation for the weight is P.D.E. So obviously we need to, when we go for the design of any shaft or bar, at that time the weight consideration is very important, and we want to reduce the weight. So reduce the weight means minimizing the weight. So that is an undesirable effect. So weight is an undesirable effect, so we need to minimize it. So P.D.E. equation will be for your weight consideration. Then second is subsidiary design equation. So what is subsidiary design equation? This is a secondary or subsidiary design equation, are the important equation other than the primary design equation. For example, we can say case of tensile bar, design the equation for tensile stresses. So tensile stresses is a secondary design equation. So that is subsidiary design equation, S.D.E. Third one is limit equations. So LE. So limit equations are the important design equation that defines the satisfactory range. So there will be a range of the particular values, or we can say design parameter. So likewise, if their value is given of stress is limit is given, so in between this to this, or torsional stiffness is given in between this, so it is a limit equation. So limit equation for the stress will be likewise sigma t equals to SUT upon NF. So this is a Johnson's method of optimum design. So three primary design equations, subsidiary design equation, and the limit equations. So these are the three equations, classification of the particular your equations are there. Okay. Now here, what are the steps? How will follow these steps in optimum design by using the Johnson's method? So first step will be select geometrical parameters. So what are the geometrical parameters are there that will be selected here? So selection is an independent geometrical parameter for the mechanical element which uniquely defines the geometry of the mechanical elements. So it is the if the choice exists, then select the geometrical parameter which are either specified or limit. Now number 2, second step we can say decide the basis of optimum design. So how we are deciding? So like weight or cost or strength. So based on this we need to decide. Third one is write P.D.E. So P.D.E equation we need to write it here. So we need to express the quantities to be optimized here in the P.D.E equation. Now next is write S.D.E and the limit equations. So S.D.E is subsidiary design equation. So write all subsidiary design equations here which express the functional requirements and undesirable effects other than the quantities to be optimized. Write all limit equations for functional requirement parameter, undesirable effect parameters, material parameters and geometric parameters. Now next is classify the parameters. So classify all the parameters included in your P.D.E, S.D.E and the limit equations. Then combine S.D.E with P.D.E. Now we need to combine all subsidiary design equations with P.D.Es by eliminating only unspecified and unlimited parameters. So generally unspecified and unlimited common parameter is eliminated from P.D.E for each S.D.E. Now next step will be determining the finding the variations of optimum design quantity. So here we will determine the variations of the optimum design equations or the quantity with respect to each independent parameters or dependent parameters which are developed in P.D.E. Now next step will be an impose limit parameters or limit equations on P.D.E. So here using limit equations determine and substitute the optimum values of each independent parameters or independent parameter group in the developed P.D.E. Now write final P.D.E in terms of parameter group. So write all P.D.E in terms of functional parameter requirement groups including undesirable effect, material parameter and geometric parameters. This is an final P.D.E equation. Now next is select optimum material from comparison table of various materials. Here we will from the final P.D.E equation using the material parameter group select the optimum material. This material parameter group is known as the material selection factors and its value will determine the maximum or we can say optimum available material. And the last step will be determine optimum values of geometrical parameters. So here the optimum values for the eliminated geometrical parameters, for example geometrical parameters which were eliminated from P.D.E are obtained by solving the original subsidiary design equations. So in this way we will solve the numerical based on the Johnson's method of optimization from step selection to the determination. So we will take the numerical based on this Johnson method of optimization in the next session. Thank you.